This is screencast number 4 for Unit 4, Lesson 1. I'm on page 183, and we're looking at the sample problem where it says, do the math. It says, use the graph to calculate the average acceleration of the train between 10 seconds and 30 seconds, assuming that the train is traveling north. They tell you to assume that it's traveling north so that you understand that we're dealing with a velocity. Okay. If you look carefully at the graph, first of all, 10 seconds is marked by this vertical line, so I made a little hash mark. 30 seconds is marked by this little line, so I made a little hash mark. Okay. At the beginning of the time interval, okay, v with a little 0, that just is a fancy way of saying initial velocity or beginning velocity. Our velocity at the beginning is 30 meters per second. Our velocity at the end of the time interval that they've asked about is 15 meters per second. Okay. Our beginning time is 10 seconds, and our ending time is 30 seconds. So you just simply plug it into the formula, final velocity minus initial velocity, 15 minus 30, and that's going to give you a negative 15. The negative really just is telling you it's slowing down and not speeding up. Okay, and then final time minus initial time. Okay, so you get negative 15 meters per second on top, and you get 20 seconds on bottom. Okay, negative 15 meters per second divided by 20 seconds gives you negative 0.75 meters per second squared north, or 75 meters per second south. If you say north, it's negative 0.75 because it's slowing down in that direction. In other words, the acceleration is not is not oriented north. In other words, I really don't think I like the way that they specified that because I think it's confusing. But anyhow, when I did the math, I wound up with a negative answer if you follow the formula, and that just indicates to you that the acceleration is working against whatever the direction of your current velocity is, meaning something's slowing down. Okay. Then we're going to do you try it on number 22. It says calculate. Find the average acceleration of the train between 80 seconds and 100 seconds, assuming that it is traveling north. Again, acceleration is the change in velocity divided by the change in time. Okay, here's 80 seconds. Here's 100 seconds. At 80 seconds, the train is traveling at a velocity of 0 meters per second. And at 100 seconds, its velocity is 20 seconds. So that's a change of 20 meters per second and a change of time of 20 seconds also. So the change in velocity goes from 0 meters per second up to 20 meters per second. That's a change of 20. Time changes by 20 seconds. So you have 20 meters per second divided by 20 seconds. And so the acceleration in this particular time interval right here is 1 meter per second squared. Now you'll notice I have a whole lot of other calculations, and I'm going to talk about this in just a second. First, I want to remind you we did something similar with the distance versus time graphs. We kind of looked and we chunked it into different parts of the graph where the line was doing different things, and that's what we're going to do right here. So if you look very carefully on page 183 at the graph, you have basically 5 sections of this graph. You have a horizontal section right here from 0 to 10 seconds. You have a straight line right here from 10 to 50 seconds. You have another horizontal piece from 50 to 80 seconds. Then you have a slope up from 80 to 130 seconds. And then you have another horizontal piece from 130 to 160 seconds. Okay? And what I did at the top of each one of the, first of all, I kind of color-coded them so that I could see my 5 different segments. And then I figured out how much time had gone by during that second. This is a 10-second segment. This segment is 40 seconds long. This one's a 30-second segment. This one's 50 seconds. This one's 30 seconds. Okay. All right. So I can actually calculate the average acceleration for each one of those segments. Okay. For A, the line is horizontal. I started at a velocity of 30 and I ended at a velocity of 30. So that is a change of 0 over that 10-second interval. So 10 meters per second, 0 meters per second divided by 10 seconds, and you get an acceleration in this area of 0. It's a horizontal line. A horizontal line on a velocity versus time graph means that you're not speeding up or slowing down. Okay? That's a little hint about what we're going to find in this section and this section. All right, but let's proceed to the next section. It's kind of hard to tell probably on your screen, but it's sort of a purplish. The beginning of this section of the graph, we were at 30 meters per second, and by the end of this section, we're down to 0 meters per second. So, final minus initial, that is a change of 30 meters per second, and we're going to say negative because we're slowing down, and that's a change over a time period of 40 seconds. So negative 30 meters per second divided by 40 seconds, and you get negative 0.75 meters per second squared, which is actually the same thing that we got up here in the sample problem. But you'll notice that this sample problem was just a smaller part of this downward line, so it's all the same. Okay. All right, the next section sort of appears red. We begin that section with 0 meters per second. We end that section at 0 meters per second. So that is a change in velocity of 0 meters per second. And the time interval is 30 seconds. So 0 divided by 30 gives us 0 meters per second squared. Again, the line is horizontal. I'm not accelerating. I'm not changing my velocity. Then we have this kind of turquoise section. I begin this section of the graph at 0 meters per second, and I end it at 50 meters per second. So final velocity minus initial velocity, 50 minus 0 gives us a change of 50. And the time interval is also 50 seconds. So 50 meters per second divided by 50 seconds. And during this part of the graph, the object is, or I guess it's a train, the train is accelerating at a rate of 1 meter per second squared. Then we have the last segment of the graph, and it's another 30-second segment, and it's another horizontal piece. So I start that part of the graph at 50 meters per second, and I'm still at 50 meters per second at the end of that time interval. So 50 meters per second minus 50 meters per second, that's a change of 0 meters per second over 30 seconds, and I get 0 divided by 30, and I get 0 meters per second squared. So you can kind of break it down into sections, and you can tell me about the acceleration of the object during the specific sections of the graph. Okay? No acceleration, slowing down, no acceleration, speeding up, no acceleration. Okay? The only place where the train is actually stopped is here because it's going at a speed of 0 meters per second. Okay? Here it's not accelerating, but it's moving at a constant velocity. Here it's not accelerating either, but it's moving at a constant velocity of 50 meters per second. Okay? So remember my hint about you can be moving even if you're not accelerating. Okay? You can be moving at a constant velocity. You're just not going to be changing the way you're moving if you're not accelerating. Okay, now I'm on page 185 in the lesson review, and I'm going to walk you through part of this graph and kind of give you some hints so that you can answer some of the questions. First of all, it says this graph represents motion in a constant direction, meaning the direction's not changing. Use the graph to answer the questions. Well, first I'm going to take a really good look at the graph, and I, first of all, am going to read the title. It says velocity versus time. And I go back into the lesson and I remind myself that a velocity versus time graph, on a velocity versus time graph, the line or the slope of the line tells me acceleration. So when I calculate the slope of the different sections on this graph, I'm calculating acceleration because my y value is velocity, my x value is time. Change in velocity divided by time gives me acceleration. Okay. The next thing I do, I kind of break it down section by section, and I am a color coding kind of person, so I color coded it. So there's this section where the object is doing something, and then there's this section. Remember, a horizontal piece on a velocity versus time graph means that the velocity is not changing. Then we have this section where it's speeding up a little bit. Then we have this section where it's slowing down to 0. Then we have this section where it stays 0 for a while. It's probably stopped. Then we have this small section where it speeds up. And then this last section is another horizontal line, meaning that it's going at a constant velocity again. All right, so I've kind of already answered some of the questions for you. What quantity can be calculated from this graph? A velocity versus time graph will allow you to calculate acceleration. Remember from further back in the lesson, a distance versus time graph will allow you to calculate velocity. Okay? All right, and because I'm just such a nice person, here we go. How is this quantity measured? Okay, so first of all, the first part of the question, what quantity can be calculated? Acceleration. And it can be calculated from a velocity versus time graph. How? By saying acceleration equals change in velocity divided by time. Okay, next, you're analyzing part of the graph. What is the acceleration from 9 seconds to 12 seconds? Okay. From 9 to 12. Well, that's one of our horizontal pieces, and it's horizontal at a velocity of 0. So this object, whatever it is not changing its velocity of 0 the whole time. And if it's got a velocity of 0, it's probably not going anywhere. Okay? Okay. Change in velocity divided by time, 0 meters per second divided by 3 seconds. Okay, so it doesn't change its velocity at all. Divided by 3, you get an acceleration of 0 meters per second squared. Okay, so it's not changing the way it's moving. It just so happens it also is probably not moving at all because it says its velocity is 0 meters per second. The graph is horizontal. It's horizontal when you're not accelerating. It's horizontal here at 0 meters per second. You're probably stopped. But it's also horizontal here at 1 meter per second. And it's horizontal here at 3 meters per second. All right, number 10. What is the average acceleration from 0 seconds to 4 seconds? Remember that acceleration is the change in velocity divided by time. Okay, change in velocity, it goes from 0 to 3. So 3 minus 0, that's a change of 3. Time, 2 minus 0, that's a change of 2. Oh, from 0 to 4 seconds. Sorry. From 0 to 4. So it still goes to a velocity of 3, started at 0. So 3 minus 0 gives you a change in velocity of 3 meters per second. And then a time interval of 4 seconds. 3 meters per second divided by 4 seconds. If you're looking at these two together and averaging them, which is what they're asking you to do, the average acceleration over that portion of the graph is 0.75 meters per second squared. Okay. Okay, so I moved it up just a tad so you could see number 10. Remember, change in velocity divided by time. It changes by 3 meters per second over that 4-second interval. And then 3 meters per second divided by 4 seconds is 0.75 meters per second. Could I break it down further and do acceleration from 0 to 2 and acceleration from 2 to 4? Yes, I could. But they're asking you from 0 to 4 altogether, and you can do that.